Thank you for having me. So my name is Rohan Primrose. I'm the design manager at PPC Moulding Services. We're a custom plastic injection moulder, also injection moulding silicons, located here in Sydney. So I'll break this up quickly into two sections, a bit of a company overview, and then some top-down design methodologies and some tips and tricks that have served me well over the last, it's been 20, 21 years. So a bit of who we are. Been in business for 12 years. I've been with the company for 11 and a half now. That goes pretty quick. You can see the growth we've had over time. So we're currently up to 100 million annual turnover across 3 sites. The most recent one opening up in LA this year. Being ISO 13485 accredited for CONVERGE for medical device manufacturer allows us to predominantly play in the medical markets to meet our customers' requirements. But we've also got an industrial arm to the business that focuses mainly mining and rail, our big customers, but also do a commercial grade moulding. What do we do? Predominantly plastic and silicon injection moulding. We've got 75 machines with a shop range of 5 grams up to about 5 kilos. Do product assembly and testing, tooling management and design, manufacture of moulding tools. We don't manufacture any tools in-house. We concentrate on our core capabilities, which is moulding. But Graham Aston, the managing director, is an ex-tool maker, so we're certainly well versed with liaising with our tool makers to ensure that we get the tools that are going to sort of meet our needs over the life cycle of those products. So we do take very close attention because it's very hard to make a good part out of a less than optimised tool. We do look after logistics and shipping, especially for our smaller customers. We've got a couple of small customers who work off the kitchen table at home, and so we're their end-to-end solution from concept, product development, prototyping, release to manufacture tooling, right through production, packaging, shipping, and going from sketch on a bit of paper to there's 5,000 on a pallet on the back dock heading around the world. So some of the range of customers from big to small. And you've seen from the presentation this morning, we do a lot of work for ResMed. So rather than talk about it, I figured it was easier to show you. So a bit about the role I play at PPC Moulding Services. I'm the design manager. When I first arrived from ResMed to join Graham, I think I was employee about number 5. I was operations manager for 5 years. Decided that was too much like hard work and I wanted to go back and play in design, which is my first career passion. But it's being able to bring those lessons learned from 5 years at the coalface, sort of seeing what sort of the impact to production and then cost and hidden costs of good design or less than well optimised design. There's a lot of things coming down to if you're having to send a die setter to go and tend to a machine every 15 minutes, it means you can't do all the other roles you need to do in his shift, so you might have to employ 2 die setters. So it's just having that sort of affinity with the direct correlation between designing on the CAD screen, what goes through the tooling process, into the tool, and then the part that pops out and the effect it has on the entire sort of life cycle of that product. We offer Creo consulting and contracting services, so we can work on site. So for my small customers, sorts of meetings in cafes or pubs and working through their design projects, and do the work at our Villawood facility. The last couple of years I've worked on site with customers. I've worked with ResMed, Nanosonics and Cochlear. We're actually become part of their design team. So I had 2 years at Nanosonics, getting out, helping them develop their Trophon product, and then also Cochlear with a couple of their accessories. So really just becoming part of that design environment. And also what I really enjoy is working with different designers at different levels, from graduates to 40 years professionals. So sharing what I've learnt over that time, but also learning from them. So I get back as much information and learning as certainly I can bring to the table. So come out of the couple of the services we provide on the Creo side, come with 20 years experience, part and product design for in-house customers and external clients, reverse engineering. They've got a part, I was working with one of the gents here, got a part that was done in the 70s and they had no CAD data or CAD files, a couple of schematics, and was able to work with them to do some modelling for the lead side of the business. Model forensics, often it's models that are built by multiple people, and I call them the orphans, and when you roll back through the model tree you can actually see, out of 200 features, this 75 was done by this designer, this 50 features was done by this designer, and then the rest was by a third designer. And there are so many different ways to skin a cat when you're modelling it, and how you go about it, and you can actually sort of get to interrogate and get in tune with the model, and then you're trying to fix those problems, because usually it's 5 minutes to midnight, you're trying to do something and things start crashing and falling over, and that's where the bead of sweat comes down your brow when you've got a project manager who's wanting to get things out. Top-down design using skeletons, and I'll go a bit more into that later, for small and simple to large and complex parts and assemblies, and that's a methodology that's really served me well over my time. Do a bit of free-form surfacing. Predominantly my experience is plastic and silicon injection mouldings, aluminium castings, and sheet metal, and there are a couple of customers we've done design work with. The big tip and trick that I wanted to share with you today that served me really well is the power of top-down design using skeleton architecture and reference control. I guess just so I'm not preaching to the converted, hands up who's using skeletons in their designs for assemblies. 1 or 2? So hands up if you've never heard of skeletons before. Never heard of skeletons? Okay, so what a skeleton is, it's a fantastic way to control geometry of parts and sub-assemblies, and also their interactions and interfaces from a top level part file, or what we call a skeleton file. So using this we can control part line gaps, screw boss locations, button locations. If you've got a free-form surface and you're carving it up across multiple parts, just to ensure you're getting that design intent and those surfaces coming through your parts. The fantastic part of them is they're really robust if you build them right. you do need to sort of look into your crystal ball and work out where you want to end and work your way back and construct them right. But it controls those large and complex assemblies from a top-level skeleton. Then you use that, what we call external copy geom, and then import copy geom into a part to filter those references down to your parts and sub-assemblies. Try and keep it as lightweight at the top as you can, so you're trying to push any references that control two parts down as low as you can. So if you've got a part over here and a part over there, you don't have the same reference control at the top level. You push those down into the level as far down as you can. The big thing I was always trained, I know the lead guys call it sloppy works, where you're just picking assembly references all over the place and then the whole thing explodes as you're trying to hit print to or export off to tooling or to prototyping. So I avoid assembly references at all costs, because that leads to circular reference hell, and that's really when you the stress starts to pick in when you're trying to get files out for tooling or for prototyping. For skeleton composition, the makeup, I use surfaces, curves, points and planes, but never solids, just to keep them really lightweight. How it works, I explained before, you have your skeleton at the top, you export copy geometry in sort of parcels or bundles of geometry down into export copy geom. That's fed into the parts. That's usually one of the top features in your model tree of the part, and import copy geom, and then that gives you the geometry that's just pertinent to that part. The big advantages of top-down design using skeletons is it gives you really robust models if you build them right, especially during those high-level design changes. So 5 minutes to midnight, at Nanosonics, a week before we wanted to send out for verification prototypes, we found out, because of certain reasons, that we had to increase the entire size of the unit by 20 mil. The unit's probably 60 long. Because we're able to do that, we generated it out, did all the changes, and a day and a half later we were ready to rock again. And that's got probably about 1,000 parts in it. Lots of panels, frames, structures, a bit of wiring, looming, lots of tubing, all that sort of thing. So it really controls, when you do those changes, controls and conserves those as part and sub-assembly interactions. So you can make those changes where you're flexing your whole assembly, but you've got confidence that if you put in a 0.5 part line gap, that's going to be conserved after your regeneration. So in terms of the amount of checking you've done after the change, you've got confidence that you don't have to go and check absolutely every little facet of your design or your assembly. And that just takes time when you've got that project manager going, get it out, I've got to tick my box, all that sort of thing. Another really good thing, and I use it when I'm just working on my own, but I've seen it work fantastically well. So, ResMed used this methodology from when I left there we started in 2003 when I first started at ResMed, when we brought that in. It's fantastic for multiple designers and multiple teams working on different parts of the assembly, where you've got a head designer that's looking at the overall shape, and then he can parcel that out to that team leader doing on that assembly, pass that geometry out to this team leader. They can work within their envelopes, confident that when they come back together, it's going to be sort of seamless sort of interaction between the parts. As long as they stay within the confines of those envelopes, they're not going to have sort of clashes or mismatch. And also the whole product looks uniform. You don't have this team with their style, and it just doesn't match the style of another one. Another big advantage, and this is when things go wrong, it creates lighter, simpler, more robust models and easier model forensics. So really encourage you to get in and use your sort of investigative tools to go back and work out where the references are, especially if you're inheriting designs